Hello, good morning. Welcome, everyone. And today, we are going to discuss a very important topic in current times. That is about the ventilation at home or at office or any of your enclosed spaces where you have uh, air handling units or AC units, or you have airflow and you have closed spaces. So, what we're going to discuss is the role of ventilation in controlling any kind of transmission, or how to mitigate. So as we all know, ventilation is an important factor in mitigating against the risk of far field aerosol transmission, but has no impact on other transmission routes. So what we are going to focus on is an important thing which we have always been designing on our building automation strategies and our air handling units and our building control strategies. So that is about the CO2 levels. We always kind of uh, have designed and maintained spaces and maintain the CO2 levels, the carbon dioxide levels in the spaces. Now, why this is important to understand is the measurement of elevated carbon dioxide levels in indoor air. They are an effective method of identifying poor ventilation in multi-occupant spaces. So we can find out if that building or that space is not being regulated properly, if its CO2 levels are higher, and if there's not enough proper airflow, circulation of air in that space or building. So as you can see, in low occupancy or large volume spaces, a low level of CO2 cannot necessarily be used as an indicator that ventilation is sufficient to mitigate the transmission risks. So we have to consider ventilation as a part of hierarchy of risk controls approach. So that's what we're going to discuss today using our Alerton program, how we can control the dampers. It could be the VAVs, implemented in VAV strategy. That's what we're going to look here on the program. And also we will look at the ASHRAE guidelines of how it is to be controlled and the strategy we can follow. I'm gonna just take you to a screen here which shows us the ASHRAE ventilation for acceptable indoor air quality. These guidelines give us a path and approach how we can control. So you can see here, I'm going to try to just quickly go through this. The oxygen consumption, CO2 production liters per minute, physical activity met units, breathing rate. So you can see the breathing rate graph, the carbon dioxide production, and oxygen consumption. And you can see if you're sleeping, seated, and you're doing minimal work, very light, activity level light, walking at a very slow pace, light machine work. And then you have moderate to heavy work. And you can see how the oxygen consumption and carbon dioxide production increases. So this is the ASHRAE guidelines that we're going through right now. I'll just so the guidelines, I just want to make sure, because this is for our reference, so we know what we are designing, what we're working on. So you can see it says maintaining a steady state CO2 concentration in a space no greater than about 700 parts per million ppm above outdoor air levels will indicate that a substantial majority of visitors entering a space will be satisfied with respect to human bioeffects. So you can see that a more detailed discussion of the relationship between CO2 concentrations and the perception of bioeffluents, as well as the use of indoor CO2 to eliminate building ventilation rates, is contained in this standard, ASTM standard D6245. Now, again, the next paragraph says that CO2 concentration in acceptable outdoor air typically range from 300 to 500 ppm. So we need to make sure that the 700 ppm limit is maintained. If you're indoors, the CO2 levels should be below 700. If it goes above 700, then you need to design a strategy or design a program wherein you are introducing fresh air into the space so the CO2 levels go down to 700 ppm. That's our set point. So this is what I'm going to discuss about. This is the set point which I'm discussing. So you see, we need to make sure. So I kind of indirectly I'm designing a strategy also. So we are making sure we are taking the ASHRAE standard set point. So what we have here, I'll just so that's 700. That's our set point. That's our set point for CO2 level. Okay, that's what we are trying to maintain. So we don't need for outdoor. If you're using outdoor, then 300 to 500 ppm is the recommended limit. So now, since we know that we have the ASHRAE standard set point of 700 ppm, so we go to our program and we will try to write a program which will make sure that your system is giving the fresh fresh air, is introducing fresh air in the space, and it is bringing the set point levels below 700 or 800, what are the set points we're using. So I'm gonna just show you the program here. So this is a specific application or based program, what we are writing in the program. I'll just take you a bit closer. So over here, so I'll show you the entire strategy, how it looks like. This is what it's going to look like, the whole Visio page. And I'll just focus on this particular quadrant, left quadrant. Now we want to make sure, the first step, when we write the program, we have to make sure that the fan status is on, that we have a system which is running, and you have an AND gate. What this AND gate does is, if you know the AND gate, 1 and 1 gives the output 1. The rest of it is all 0. 0, 1, 1, 0, 0, 0, the output is off. So both the conditions should be true to have an output which is true. So that is what this AND gate does. So we have fan status and we have an input. We have a CO2 limit. What we have taken here is 800, slightly higher than the set point of 700. So we can even adjust this here. So we have the AV value and the AI value. AI is an analog input, that's the current value, that's the actual CO2 sensor reading, and AV is analog value, that is a set point. So this is what we are showing here, AV81, and then we have a 3 and 3 trigger and reset dead bands. So here we have taken 800 for this particular application. For whatever reasons, we are just slightly keeping it 100 ppm more than the set point committed by ASHRAE, 800. And we have a current reading of 1100. So we are considering this space is either not properly ventilated or it's heavily crowded. A lot of people crammed into a space. So that's what this current program is telling me. So basically you can become your own Sherlock Holmes. You can deduce that this space is currently overpacked, not having proper ventilation, or something is going on. So you need to immediately do. So this is what's happening here. The current space reading is 1100 ppm and the set point is 800, so it's more. This is the comparator. So if the plus input is more than the minus, you get the output which is on, and the AND gate meets both the conditions are on, so it enables the system basically. So you see it has immediately turned on the system. This is enabling it. And then you have Kp proportional in integral constants. Here we have kept it as 5 and 1 because our response rate is okay with these values, so we can use 5 and 1. The set point we have taken is 800 CO2 limit set point, and the feedback is, that's our current value of the CO2 is 1100. So based on the calculations, we can see that it's calling for 100% ventilation. This is the limiter between 0 to 100. So it's calling for full ventilation. As you can see, immediately turns on the switch because this is BV50. Again, that's the same condition we're using, that the system is calling for full ventilation, and it gives us a decarbonizing signal. If you can see here, what we have is a decarbonizing signal. So we are calling for the system to decarbonize. That means that we want the system to ventilate properly. So this is the program we have written to make sure that particular space is calling for fresh air. What this is doing, what this output means, I want to focus on this. This output is basically calling for the dampers to fully open. Regardless of what the set point is, even if you're feeling cold, this condition, because it's a high priority condition, you don't want CO2 levels high in the space. So regardless of, even if you're freezing, even if you're calling for heating, it doesn't care because your CO2 levels are high. So it's calling for full ventilation. So it's open the VAV box until the ppm level goes back to the set below the set point. So this takes priority. So this should be understood clearly. Our first priority is health and safety based on ASHRAE conditions, regardless of if you're feeling cold and hot, because it's not a life-threatening or it doesn't affect your health that much. So we need to open the dampers fully and bring in fresh air into that space. Okay. So again, this is another space we are looking. Say, I'm just going to show you a bit of more programming side also here. So if you can see the program here, you have the next VAV box input number 3. The CO2 is way off the charts. I think there are too many people partying in that space or whatever. I'm not sure. A meeting taking place and it's not properly ventilated. 2000 ppm, 800 is the set point. Again, the fan is on and you're calling for immediate ventilation to be open. And you see this KPKI. So this KPKI is immediately programmed to analyze in KPKI 1 and 5 proportional integral constants. Set point is 800. Current value of the CO2 is 2000. And then we're calling for full ventilation to be energized. So we're opening up everything so as to have fresh air, regardless of what the set point, temperature set points are. We are not caring about the temperature or comfort level at this point. We're considering and giving priority to health and safety. And you need to bring those CO2 levels down to have to maintain a proper CO2 level inside the space in question. So these are the cooling and VAV open close commands, and then the cooling damper open status. So we have a full open condition. So this is what we are trying to do. So this is the program for the CO2 and what we're trying to do is have fresh ventilation. Now with these CO2 levels, as we were discussing earlier, these CO2 levels do indicate there's not proper ventilation in that particular space, office or hall or whatever area you're working on is not having proper ventilation. So immediately you need to rectify and take action. And this is what the BMS, what we're programming in, with our Alerton system is that we need to open up the damper. So this is the strategy, what we have written. This is the logic. I keep saying strategy because I was working in England for trend, and in England, trend strategies. Basically, you write a program logic and you should refer it as strategy. So this logic is basically is measuring the inputs of the current space CO2 levels and the set point. And if the set point is being if the set point is breached, if there are higher levels of CO2 in the space, immediately we program the dampers to open fully and bring in fresh air, regardless of what the temperature set points might be. Health and safety takes precedence, and it's important for us to maintain proper CO2 levels. And so this is the program. So hope you've understood because I've shown you the ASHRAE settings as well. So this is the CO2 program for maintaining proper CO2 levels and maintaining fresh air quality inside the spaces. Thank you for watching. Do like, share and subscribe so I can keep making more videos where we can learn and grow together and share a bit of our knowledge, whatever we know. Thank you so much. Have a great day.